Alright, today I want to talk about reduction and oxidation of atoms in compounds during chemical reactions. What I need you to remember for this entire video is oil rig. This is a little acronym that's going to help you remember the difference between reduction and oxidation. Other teachers have other acronyms. I use this one because it clearly tells you that oxidation is a loss of electrons and reduction is a gain of electrons. Now remember, electrons have a negative charge. So if something's losing electrons, the charge is becoming positive. See, subtracting a negative. If you're gaining negative charges, your charge is going to get more and more negative. Now, there's an official way to assign a charge to each of the atoms in a compound, and that's something called oxidation numbers. Feel free to take a look at that video, but you can also do this in a more ghetto way by just assuming that each of the atoms is going to have the charge that you would expect it to have. Take a look at this. In this particular chemical reaction, what's the charge on copper? Well, there is no charge. And actually, the oxidation number of copper here is 0. I'm going to write a little 0 underneath of it, just to remind myself. Here, I've got 2 bromine atoms. What's the total charge on this molecule? Well, there isn't one. And I would expect the 2 bromines to be about the same. It's a covalent bond between the two. I would expect each of the bromines here also to not have a charge. In this compound, though, I've got my copper bonded to 2 bromines. Now, when copper and bromine are in a chemical like this, it's called an ionic compound. The copper, in this case, wants to have a charge of +2, and each of the bromines wants to have a charge of -1. Notice I have 2 atoms that have a charge of -1, 1 atom that has a charge of +2, and so the charges eventually cancel each other out. Another way to think about this is that the ions that make up this ionic compound are the copper 2 ion and bromide ions, which have charges of -1. Anyways, here's my point. The copper atoms went from a charge of 0 to a charge of +2. So, if you go from a charge of 0 to +2, what happens to your electrons? Electrons have a negative charge. This guy lost 2 negative charges. He lost 2 electrons. A loss of electrons? Let me take a look here. It says here oxidation is a loss of electrons. So the Cu has been oxidized. That's how you can tell. The Br had a charge of 0 and the charge changed to -1. That got more negative. Each of the bromines gained 1 electron. A gain? Well, I do believe that reduction is a gain of electrons. So, the copper was oxidized and the bromine was reduced. Check. One thing that I do want to point out is that if this was oxidized, what caused that oxidation? We say that the thing that caused it to oxidize, in this case the only other reactant that could have caused it, we call that thing the oxidizing agent. It causes the other atom to be oxidized. Now, it doesn't have to be a particular atom, it could be a compound, but the reactant that is reduced is usually the oxidizing agent, and the atom that was oxidized caused a reduction to happen. and it's called the reducing agent. Just throwing that out there. We can do the exact same process here, and I'm going to do it quickly to show you how quickly I want you to be able to do it. Ionic compound between copper and sulfide. Sulfide usually wants a charge of -2. Look it up. Copper then wants a charge of +2, so that they cancel out and you make a neutral compound between the two. Hydrogen, 2 hydrogen atoms connected together with no charge total. Well, it's a covalent bond. They probably both have a charge of 0. Here, copper atom, no charge, charge of 0. Here, polar covalent compound. We've got hydrogen connected to sulfide. Well, sulfide is a charge of -2, and each of the hydrogens could want a charge of +1. That story checks out too, valence-wise. So, which chemicals here had a change in charge or oxidation number? Well, I see that Cu went from a charge of +2 to a charge of 0. That seems like it's getting more negative. In order to go from +2 to 0, it had to gain 2 electrons. Gain means that's the thing that was reduced. What else changed here? It looks like hydrogen went from a charge of 0 up to a charge of +1. To get more positive, you had to lose 1 electron. And in that case, a loss of electrons? Well, that's an oxidation. So, the copper was reduced and the hydrogen was oxidized. Notice the sulfide or sulfur atoms, that charge didn't change. The oxidation number didn't change there. It wasn't reduced or oxidized, but it was still there. Best of luck in assigning oxidations and reductions to your chemical reactions.